That's where we focus on in the second lecture. As I told you last week, I want to do the Kotlin language in the first lecture, and in the second one we start to have a look into Android, and we go and doing this in parallel. So Kotlin is not that hard to learn, since you all are able to program in either C, C++, or Java, mainly Java, I think, and you know this syntax, and the IDE IntelliJ is helping us lots of things, lots of problems to solve, really good, so that we can start from scratch a little bit. But I want to give you a deeper advice in Kotlin 2, so that you understand the building blocks and understand how to write better coded Kotlin applications and use the features from Kotlin really good. Maybe you already had a look into this Kotlin cones online tutorial. It is really nice as well. You get some easy you get some exercises which are especially for the highlights of this Kotlin language. So they show the different highlights, where Kotlin is much easier to use in case of Java, where we just reduce the amount of code, the amount of syntax we have to write. That's the part. This is what Kotlin cones shows us. That's right. JavaScript is a big influence into Kotlin, Java, JavaScript, also C++, and Python. Influenced this Kotlin language. And we can generate code with a Kotlin compiler for Java Virtual Machine, for the native processor, and JavaScript as well. Yeah, this is also really nice. You asked me this in the last lecture, why not earlier invented a programming language like Kotlin? Why did it take so long? If software companies have their running software in programming languages programmed, they normally do not plan that after a period of maybe 10 years they change the programming language and reprogram their complete software projects. This is not in the plan, and that's why they stay in the programming language they already have and do not switch. The programmers are professionals in the programming languages the company's software is programmed in, and there's no reason to change. Why should they change? And new companies maybe start with new languages because the students or the beginners in those companies have the knowledge about new languages, and we teach those languages, you learn them, and they are new, and it's not always the same. So newer companies, newer workers maybe bring these new languages into the companies and in new projects. Then you find those, and it would take a long time, many years, that a programming language is established somehow. Yeah, you need programmers that like this language, that program this language. And Kotlin has another advantage in this way. As I mentioned, we can program Kotlin and compile for Java Virtual Machine, compile for C++, native code, or JavaScript. So all projects that are already in JavaScript, C++, or Java can be supported or can be combined with Kotlin code. So we do not have the need to completely reprogram Java software. We can just convert the Java code into Kotlin code, or just adapt the Java code in the Kotlin code. The running software is then adapt, and now it's from this point it is a Kotlin project, and we can successively change the classes or the packages into Kotlin classes and Kotlin packages, and then it is not the need to say, okay, throw everything away and start from new. This is another advantage I would see here. So, but now we want no moment. Another thing. I have some exercises for you too. And now let's see. I have a internet address. It is called procon.hove-university.de. procon.hove-university.de. If you follow this link, a login screen, login dialog, and you should have from Hove University a login. So you can use your login from Hove University if you have one, but you must have one because you are in Moodle. So since you are in Moodle, you should have a login for this site, and I can log in with my Microsoft name here in Hove University, and then I come into this portal. This portal is giving you everything is in English, so you can read and understand, and you can use it. Here you have a list of problems, a list of exercises. These are just different kinds of problems, algorithmic problems, and you solve it not with an Android application, so you solve it with a command line Kotlin application. Oh, my camera has stopped. I try to reboot it a little bit. You can do it with Kotlin. I just added the Kotlin language. Just read about any problem you are interested in. You have your solution, or your running program has only a amount of time that it may run, or that it has to solve the problems or the tests which are giving into the program, and it has only a amount of main memory which it is allowed to occupy for the solution, and you get some experience points. This is just for fun, so there is a high score at the end and you get some experience points here. That's the task. Maybe here a problem description, and it is a simple input-output program, so you get some input, your algorithm produces some output, and if the output is correct, your program is accepted and you earn the points. That's in short the thing. The problems are mainly mathematical problems, so it's our algorithmic solutions wanted here, and you have to care about data types and sizes of data types. You have to care about how to read input and output correctly, but we know we can use the scanner from the Java util, and the print methods from Kotlin to do this, and this is no problem. Then you have to find an algorithmic solution which is from the complexity and the time and space complexity according to these restrictions here, and if you have that, you get the points. Some examples, input and output is given to every problem, so you can see what is the input and what is the expected output for some tests, and there are lots of more tests you don't see here. You have to pass all tests, not only the ones they are written down here. You have to pass all tests, and in some problems you have additional notices down there. Maybe I change to one of this. There you have a note which explains the solution here, why it comes to this solution. So you can see if one of the problems is nice for you, and just read through those problem descriptions and say, oh, I have a solution idea and I want to solve it. That's additionally to these Kotlin cones, so it's from us here in Hove University, this platform. If you submit your solutions, you see it here then. The last solution is coming from a student called P. Bear. It was yesterday night, a nightly build, but he got the problem completed. If you do not complete it, you have several chances, unlimited chances to try until you come to a complete. If you complete all tests, then you come to this completed, and if you come to completed, you then earn points. So if you complete all your problems we have, so after several tries, then you get points, and the sum is then your high score value, and this is shown on the scoreboard. As you see here, some students, they are programming C++ actually in my course, and they have those problems as exercises 2. They started several weeks ago with this platform, and last week I added the Kotlin language, so now we can use Kotlin. And if you choose Kotlin, you choose a file from your computer and your solution source code file and submit it. It will be compiled and run in a jail. In this jail there's nothing in it, just all the standard libraries you need to solve your problem, and not more. And then you can see in this number, or if you click on this, you can see the tests which are done with your program and the program code and so on. No. Okay. Any questions to that? Yes, please.
No, none. We are following up with what you're doing. I've been able to log in, so practice that from time to time.
You are you able to log in or not?
Yeah. I'm currently there now.
Oh,
So,
okay.
yeah.
Fine. That's nice. That's nice.
I have a question, please.
Yeah, please.
For the exercises that you on this platform, are there specific language, or we can do any kind of language in general?
In general, you can do any kind of language, but I would prefer that you use the
Of course, Kotlin.
the Kotlin language. That's right.
All right.
But if you want, you can try to solve the problems in different programming languages too, and you can solve it several times. Yeah, it's no problem.
Okay.
You can solve if you want to say, if you say, oh, I will try it in C or C++2 or Java maybe, and Kotlin as well. Then you can give 4 solutions, and if they are all good, then you get only one time the points. You know,
Of course, yeah.
yeah, but every commitment will reduce the amount of points you get. This is written down here, but I see here in this Microsoft Edge, the mathematical library is not really fine interpreted. Maybe
Yeah,
you
well precise, yeah.
yeah.
I know.
Normally there are more braces, and there are some. It is a little bit written down others. It's not really correct here, but I think this here should give you the how it works.
Exact points.
Yeah,
Yeah.
genau, that's right. Okay, so the camera is on again. Or
But we can't see you, we only see the chair.
Yeah. You see only the chair. No, the camera is missing. I use my smartphone as a camera,
Right.
and it is a Android smartphone, and the application running, this DroidCam application, is here in the tray. Android Cam application on my smartphone sometimes brings the UI, sometimes crashes the UI, and I have to restart the phone. This is not every time. It can go 3, 4, 5 hours without problems, but there are days after 90 minutes the phone crashes. I don't know why. Um, Maybe I need another phone or another application.
Are
So
you using the Droid or the Droid X?
no, it's the Droid Cam application.
Because the more professional is Droid X.
Ah, okay, okay.
I think you must pay for it, I think.
Ah, okay. Could
But
be,
it's
could
not
be.
too much. It must be around €4. Or
Thanks for the hint. I know there are other applications that are free, and I could try another one. Last year or 2 years ago, with students in a smartphone programming course, we did such a software too, but from smartphone to smartphone. So we've written an application with the students during the course. At the end of the course, and they used the camera and sent the image via UDP to another phone or a PC or whatever, and this could be it's really easy to program for the Android phone. So I don't understand why this brings my phone to crash. It's it's not rocket science to make such an application. So I don't know why it crashes. It's really crazy.
There could be so many factors with regards to the reason why it's crashing. It could be the mobile device itself, or maybe from the code, the written Android code. So
that's right.
it's
Yeah,
possible.
that's right. So normally,
Or
normally
yeah.
the application should crash earlier than the mobile phone, because the application does not crash. The application is still running, but the mobile phone is not reacting anymore. So
So probably it could be from the mobile device itself. Probably RAM usage is not optimized well or something like that.
yeah, that's right. That's right. So it is not a Samsung. This is true.
Okay.
Yeah. Okay. Good.
the other problem is that sometimes you seem like a ghost. Half of your body doesn't show up and appear.
Now this is a question of sky of this. What do we use here? Zoom. This is a question of Zoom. So the background is not the real background of this room where I'm sitting. It's from the neighbor room.
Okay.
Yeah, it's next door. So what you see is the room next door. Okay. We jump into Android now and hand over. What we want to do in parallel is have a look into the Android operating system and into mobile computing as a whole. Yeah, what's the agenda? We want to have an overview over the Android operating system. Here maybe a little bit historic perspective. It should not should not be missing in a Android course. Some look into historic evolution. We will have a look into which kinds of devices are supported on this operating system, and then after this little overview we go into the development environment. It is similar, the same as we use for the Kotlin development. We have a IntelliJ. Here is a branding called Android Studio, is the same as the IntelliJ IDE, but it looks a little bit other and has some other tool integration, especially for the Android SDK. So we need a SDK to program for the Android platform. this is integrated, or it comes with Android Studio, or is installed during the first start of this IDE. And as you know, if you want to develop Java code or if you want to develop Kotlin code, you always need some SDK. There is a tool chain inside, and we should have a look into this SDK, where it is stored on our PC, what tools are there available, what is in there in fact, and how does it work a little bit if we create a emulator and so on. These are things which we have here, and if we develop for different versions of Android platform, we find those differences here as well. So we should have a closer look into this one, and then we start programming and introduce some fundamental things. So what are the Android activities, how to get a Android program run, how to get a Android program interact with the user, and what are intents, what is the intent system, what does it do for us or for me if I develop Android activities, how can activities interact with each other, how to find the correct activity for the correct intent, what is so this is a fundamental aspect of this Android operating system, and every programmer which has already made some activities knows about intents too. Then we have to learn how to create several resources, especially layouts. Everything we do in Android is how to say, we have on the one side we have the running code, and we take away all the artifacts which are not needed, all the strings, all the things we can make in an international environment we can translate, and so on. And the layout informations, where are which graphical elements shown on the device, we can do this out of our code in other files, and all those files are called the resources. We have lots of resource files. Mainly we have more resources than actual code to write. Especially when we use Kotlin, we write less code, and we have lots of more things to do in this part here. And then, interesting for us in an international team like you are, we have to have a look into internationalization, and that's quite important, because those platforms and marketplaces where we can place our applications later, we can decide in which on which continents, in which countries we place our application, and the users with their smartphones are then able over the Play Store maybe to download or pay and download for your application and run it. And they should have a good look and feel, so good layout and good readings of the application in their own language, maybe. So in parallel we do a little bit Kotlin. Okay, questions so far? Then let's have a little look into the history. The Android operating system was originally developed under the roof of Google, and at the moment it is not only Google who is doing it. It's called the Open Handset Alliance, and there are several companies which produce the hardware too. So Samsung might sit in this gremium, in this consortium as well, and they are developing the new versions of the Android operating system. It began in the year 2008 with the first official version and was further developed until now, still going on. Those versions all got name suites. So starting with a OS called Cupcake, followed by Donut, and so on. I've written them here down. Maybe you know some things like ice cream sandwich, jelly bean, Kit Kat was really popular, and then came some others, and it ended after Oreo and Pie with the sweets, with the names of the sweets. They got now back to just numbers. So we have Android 10 now and Android 11. And next to the operating system numbers, which are major numbers, so we have those. This is a minor number, so we have 1.5, but this is, I think, the only one. We have then 1.5 to 9, so we have some minor numbers here in between. Sure, it are more than 9 different suites. Why several OS versions got productive with another minor number, but now we have those major numbers similar to Java as well. So Java has always the major number 1 and changes just the minor number, and now we are used to see a Java version 13 and Java version 14 and so on in a cycle which is 1 year long. We always get a new version every year, and it's just only one number counting up. That's the new approach, and it is the same you find here now. According to a operating system version, you have especially the API level. The API level is not really derived from this number, so you cannot derive the API level from this number. The API level is the changing while the system, the operating system, is developed further, and every new version of the API, so the API is that what you can program, is your programmer's interface. This gets new versions, so new classes, new methods, other parameters, other attributes, and new features that are available for programming. So there could be features in a Android version here maybe, which are available, but we cannot program those features because there is no API accessing this feature for us. So it is not open. The APIs open those features for us as programmers to use it, and they have different versions. And this version is counting up. So the API level is counting faster up than the Android OS level. During one cycle from one OS to another, we have several changes in the API level. So this is especially a speciality of Android. We have to recognize the operating system level when we produce software, but even more we have to recognize the API level when we produce software, because of the APIs is that what we program. And the API level in first gives us the compatibility for which operating system version is compatible with my program. So I say I program the API level 30, then my application is only able to run on a Android version, operating system version 11. Yeah, we have to recognize a little bit. So we should say it is, if we don't need the features which are new in this API level, we should go to the oldest API level we can. And that's the reason that we support as many different hardware with the with those different Android versions as we can. Yeah, because how old is your smartphone? If you think about, so my smartphone is not 1 year old, but the one I had before is 8 years old, I think. So I have some devices here. Let's say what the next one comes. If you don't have questions, I advance to the next slide. There we have different devices. I can show you some. This is my old smartphone. It was a Google phone. It was the yeah, now you see it. Okay, it is made. It is. They make it away. Yeah, this is Zoom. Zoom just zooms it away. It's a Google One smartphone. It's the first one which had the RFID antenna in the back. So it has a RFID antenna. It was maybe 2010, I think, 2009 or 10. So we have here. You can't see it. It's too small. But here is a antenna in the back, and my task was to produce applications with RFID for a portable device, and we used smartphone, and this was the one where we said, okay, we switch to Android and leave the old Java Micro Edition behind us. Yeah, it's still running. Okay, what else? I have some newer phone too, also from a project. It is for outdoor usage, so you have a very hard cover, a very huge thick phone. You need a big hand to grab it, and it is very hard. You can kill somebody with this thing, yeah, or bring him into the hospital. So if you fall down from a big house or from a mountain or something in the outdoor, then this is a really good phone to have. You can do it underwater. Nothing will happen with this phone. So also a Android device. And another Android device, maybe you know this, these are those these watches, so such a smart watch, you can wear it, is a wearable device, and it can communicate with a smartphone. It is, as a standalone, it is very limited because it's too small, and we have to make good applications out of this. We have to combine it with a smartphone which has more power, which has a bigger processor, which has more memory, which is a really a computer. If you compare a modern smartphone which maybe has a processor that has several cores, so it's a multi-core processor, and you have several gigabytes of main memory available, then your phone is faster than a computer from the year 2000. Yeah, and this is just 20 years away. So all of you can remember, I'm sure, the how a computer from the year 2000 looked like, and what a monitor it had, and yeah, and so. And your phone now is sure more powerful than such a computer from 20 years ago. And this is really a big evolution in this market. It's a really fast growing market, and yeah, there are many people out there who do not own a device, and if we can make them affordable such a device, and if we have the network that is needed to use this device really good, if they can afford those things, then there is still a market growth you will find in the future. So so mobile computing is really not finished at the moment. It can still grow. And if you see that the cars get more and more a mobile device and more intelligent, then it should be maybe in some time possible to produce a own application which is running on your car. No. Eventually. So, or you speak into your phone and say, I need a car for shopping, and then the car comes automatically driven to you, finds you because you wear a smartwatch, and then you, or driving automatically to your shopping mall or where you want. Yeah, if we think about mobile computing, we have seen there are different devices, tablets as well, but I don't have a tablet. I have a self-made device here. Maybe you see it. Can you see it here? Yeah, it's too big. It's too big. It is actually just a testing device. You can't see it. Now I'm away. So I'm a magician. Now I'm away. Now I'm back. So you see it. It is just a testing device I built myself, and there's a Raspberry Pi inside. For the Raspberry Pi, actually, an Android put OS is available, so you can build with the Raspberry Pi. You can build up your own smart device, your own mobile device, or whatever, and program Android applications for that. No, this is also interesting. Okay, good. The global market share. So this is an old picture. I don't have access to the Statista. This is a web page. We have access from Hove University, but I'm actually in home office. That's why I have no new picture from 2020. But I think in 2016 it was 86%, and now we are around those value too. So I don't think that we are now over 90% because of the Macintosh, the Apple company, which is also producing nice devices, and other companies, maybe Microsoft too, producing mobile devices that want to have a place in this market. But in 2016, you see the blue part is a Android running device. So most devices were running Android. And if you think about, I want to do a mobile application, which operating system should I program for, then I really see the answer is blue. And the other ones have maybe a problem. Maybe it is easy as well to program for this red color here. This is the iOS operating system, and then you are able to run on the Apple devices, and the other ones, they have a problem, but it's not so interesting because there are not so many people, according to the money you can make with this here. Okay, good. What else? These were the devices, and with the devices we are we should a little bit think about what applications are possible with all those devices. What applications could we imagine? So that's why mobile computing is interesting, because we have lots of applications that aren't yet established, that aren't yet made, that aren't yet done, that are possible in future, and that's why it is interesting for us to learn how to make applications and then think about what applications can we imagine. So to understand the word mobile in the context of computing a little more, we can do in theory, or we can think about in theory, what is mobile and what is not, and if something is mobile, what does it need to work while it is mobile. So when using computers, we have always a user. This is the guy who is using the computer. Yeah, we need him mostly. It could be an algorithm as well, okay, but mainly we have, for those devices, we have a user. And we have the need of devices. So the user uses a device, and the device has the need of a network to do something with the device in computing the user could use it as a standalone device, but normally, and all modern devices support networking, we use it in a network. And on top of that, if we have devices, if we have networks, we need applications. Also, the user has to afford a device. The user has to access a network and afford this access. And then we need applications which have also, or which must also be affordable for the user. And now we bring everything together. Then we have a mobile computing. And let's think about what is mobile and what is not mobile. What is mobile computing in this context? If it can be, everything of this can be mobile or fixed. The user can be mobile or fixed. If the user is mobile or fixed, we have to think about the approach, which application or which usage of a computer is in a special case happening. So if the user has a laptop computer and is using it in a hotel, maybe wireless LAN in this hotel, or a plug for the hotel network, the user is not mobile while he is using the computer, because when he is using this laptop computer, it is maybe quite heavy, and he is not holding it on one hand, so it is too big. That's why he is mobile. He can take the computer in the hotel, but when he is using the computer, he is not mobile. So in this way, only the user is mobile. He can take the computer with himself, but he cannot use the computer while he is moving. This is one aspect of mobile computing. The other thing is the device could be mobile. Or let's read some more of those examples I have printed here for you. So if we think about a PC in an office. A PC in an office, the PC isn't mobile, so the device is not mobile. It is standing in the office. If I want to use the PC, I have to go into the office. I can't take the PC with me myself. So, okay, 20 years ago we only had PCs, and the students took those PCs in every direction in the world and made their LAN parties or other things. And hey, I brought my PC with myself. But today, I don't think somebody is bringing his PC to a party. So he is taking his mobile device everywhere he is going. Okay, this is not mobile. So the user isn't mobile. He has to go in the office to use the PC. If we use a tablet, maybe in a train, we are mobile. The train is moving, and while the user is sitting in the train, and the tablet is a mobile device. It can be used during the user is moving. The tablet or the laptop in the train could be seen as a mobile device, because we are moving while we're using it. But this is just especially for the train. If we use the tablet or the laptop in our car and we are the driver, this is not so good. It is not allowed so far. Yeah. A local area network. This is the normal cable-based local area network here. A local area network, or maybe a wireless LAN, but locally in a local area, is a fixed network which has fixed borders, and if we want to access this network, we have to be there, especially there in this area of this network, and that's why this is not mobile. Yeah, this is not a mobile network. On the other side, a cellular network based on cells which are occupying a much bigger area, normally a city or maybe a whole country. In a cellular network, it is possible to switch between your cells and hand over your network connection. And this is the base, the network base you need for a mobile network and mobile applications. This is a mobile network so far, because while I'm moving, the computer has network access and the application is working while you're moving. So we have this, or we need this kind of networks for mobile computing. That's true. Metropolitan area networks are similar to those cellular networks. It are networks which are available mostly in big cities where we have many users in the area, and therefore we have something like wireless LAN in the subway station, or wireless LAN in the pedestrians precincts, maybe. So you have not only the cellular network approach, which is with a network provider you have to pay for. So here you have a sometimes public, open and free network access with more bandwidth, but you share this bandwidth with the other users which also use the same network in the pedestrians precincts, maybe. But it gives the possibility or the opportunity to walk through the precincts, to hang out and use your mobile device. This is also a approach of mobile networks, those metropolitan area networks. A little bit similar, the wireless LAN, but as I said, like the local area network, you have to be in the area of this network, you have to move there, and if you want to access the internet while you do a download or so, you may not go outside this wireless LAN, and that's why you are not mobile while you use this network. You are mobile while you use those types of network. You have network in your subway. You can sit in your subway train and watch a film and do not have to pay for, and you do not have access to cellular network in the subway because you are under earth, underground. This is needed for applications, for wireless applications and for mobile computing. We have to keep it in mind a little bit. So what other devices do we have? We have the smartphones. The smartphones are really lightweight. We can hold it in hand, by hand. We can put it in a pocket. A tablet is a little bit bigger. We cannot put it in our trousers. We can put it in a backpack or in something we have hanging around us, but it's a little bit bigger. It's not so handy. A smartphone is a little more handy. We can have it wear it in the trousers or in the jacket. We can have it hold it by hand, and it's not that heavy. And that's what a mobile device has to be. To go around with it, to have it running while we are going, to have the applications running while we are going and watching on them. On the devices. More and more young men, you see them out there having their smartphone running while they are walking over a street with traffic crossing, so that is maybe not so secure what they are doing there, but it is done and it is possible, and this is mobile as well. We can use smartwatches. If we use the smartphone during sports, we always have to wear clothes where we can put it in. So I think you do not hold it in your hand, the smartphone, and go jogging or do some other sports where you need both hands. So you have to put it in some pocket, and that's then you need enough clothes with pockets to put your phone in. If it's summer, you are maybe clothed very short and you don't have enough clothes to put your smartphone in, then a smartwatch should be more interesting, maybe for sports. You wear it on your arm, do not need any pockets, and you can read maybe your emails or an SMS, or you can speak with somebody over your smartwatch. Or just check your heart frequency or some stuff. So it's very limited here, and normally you use it in combination with a smartphone. The smartphone is in your closed somewhere in your pocket or in a backpack, and the smartwatch is the one you are looking at if there is something that needs your attention. So what else? Listening to music at home. This is something where we do not really need a mobile device. So at home there we can use fixed devices somehow, but since the mobile device is mobile, we can use it at home too, and especially in every room. So if we have to do some homework and we have to switch room, go in the kitchen, in the living room, or in our sleeping room, whatever, we can take our mobile device and listen to the music. The other approach would be we had to go in that room where the fixed installation is available, where we have big speakers, where we have a radio available, where we have network access to some streaming services that way, and the smartphone does have everything we need. We could use the earphones maybe, and do not disturb other people in the same room, and this is really interesting for mobile computing as well. So we can do it everywhere, not only at home, if we use mobile computing for listening to music. The same watching a movie. We could watch a movie in an airplane. You know, airplanes have the possibility, the bigger or the more expensive airplanes, they have video in the seats. So you can a display in the seats or over the seat, and you can watch a movie. It is also mobile, so while you are flying, or maybe in a car, if you sit in the back, you can watch a movie on a display while you are moving. The user, he can watch a movie or listen to the music, and this is a mobile approach. This is as well mobile computing. Yeah. Just in the car, you sit in the car and you have an internet connection and listen to your favorite podcast or anything else, something that is serviced over network. Then the car is your wireless device moving in a cellular network and accessing services, applications which are provided over network. So the car gets the mobile device and the user is mobile with the car. This is mobility 2. Yeah, writing emails in the office. This is not a mobile approach. We need a network, but since we are in the office, we normally have network access, maybe through a PC, and then we can use this PC to write the emails. Yeah. This would be a approach where we are fixed. Everything's fixed. Okay, what else could we do? We could collect data into a spreadsheet, and this is a approach which could be more or less mobile, since we go out with a mobile device, a tablet maybe, in a pedestrian's precinct, ask some people about some information, write this information into a spreadsheet, save it and make some statistics. This would be a mobile application too. So collecting data into a spreadsheet is normally not a fixed application, can be a mobile application, can as well be fixed, could be a website, and this website can be accessed via PC from an office. So you write every interesting user an email, please fill in my my forms, and I want to statistically analyze the data, so I collect it into a spreadsheet and analyze it later. No. But the website can be accessed from a mobile phone as well. So websites are part of many mobile applications. There is not always the need to program a application that is running directly on the mobile device. Other applications, and there are so much more, are maybe paying goods in a market. Today you can pay with your smartphone, maybe with the RFID applications, or via any applications that communicate over Bluetooth maybe, or you just give some data into your phone and say, okay, now I pay this bill in the supermarket or in the market store somehow with a mobile. This is also mobile. We could use our credit card. The credit card is in this form part of the mobile part of a application. This application has a fixed part. This is the device where you put your card in, or where you lay your card on or hold it on, that this device is communicating over network with your bank account, and then you give in your PIN number. You know this procedure, and it is paid from your account. So this small card is needed and is mobile. You can take it with you, so everywhere you go you have access to your bank account. You can pay things. Yeah, this is nice. This is a mobile application too. And if we combine this mobile application with a smartphone, we can use it on the field. So with our bank account, with our bank card, cash card, we have to use it in a market or in a store that has a device where we can use the card with to access the bank account. If this software that is running on this device is also available for Android devices, we could use this paying in the field without any buildings, without anything. Just a network access is needed, and then the smartphone will be the device where we access our bank account, and we could transact some data, maybe in the pedestrians precinct. Your neighbor asks you, have you $10 or so something, and we do not use or do not have any cash money, because in the future maybe cash money is something from the past, and that's why we have to give somebody maybe electronically some amount of money, and therefore need a device that is able to realize this application. Okay, other applications, and they are already done. Find the nearest restaurant. These are applications which look into the local surroundings where your phone is via GPS in this form, and find some tagged information. So find some coordinates which are tagged. There is a restaurant, and then it shows you some restaurants, and you can say, bring me there, and how long does it take? So I have 30 minutes or 1 hour break, and I want to eat something. How can I manage this meal? Is it enough time for me to go there by foot? Is there a place free? Do I have to wait? Have I enough time to finish my meal and come back to work, or to the meeting or to anything I want to do afterwards, maybe. Yeah. So, or just navigation. You all know navigation is a mobile approach because everything is moving. The user, the device is moving, and this is the standard mobile application you have in every mobile device. So the car or the truck when it's moving, it's going to its destination. He is using navigation because the trucker that is driving through Europe, that is driving through Asia, Africa, or America, he doesn't know every railway, every street, every highway, and every destination he is going to. So he needs a navigation. Yeah, and this is the main mobile application you find everywhere. And other application is share impressions about your day, maybe. So this is typical a mobile approach. So you are somewhere, you have a nice feeling, a nice impression. You make photos and tag the photos where you have made them and say, hey, this is a nice place, and I post it into my community somehow. And this is a mobile application too in this way. So the fixed approach would be I make the photo with my old-fashioned photograph device and bring it back to home, and then use the cable, put the photographs on my PC, and then load it from the PC into the network, and then show it to my friends. So how often do you do that? You do that maybe once a month or 4 times a year. And if you can share the impressions just at the moment you have it, this produces lots more content because it is easy. Just click and send and finished. You know? So this is a mobile approach or mobile application too. And much, much more. I think as long as I talked about mobile applications here and just talked about those examples I was writing down for you here, you had enough other own examples in mind since that. But that's what it's all about. We have to think about what is mobile, what does have to be mobile that my application is working. Does my application has to be mobile? Which opportunities does my application earn when I realize it as a mobile application, when I realize it or when it is running on a mobile device, and maybe it is a web-based application, then it is running in a browser, and this browser is accessible over the mobile device too and over the PC too, so I can design applications that are able to be used in a fixed and in a mobile environment. Maybe it is the first thing I should imagine. Do I really have the need to go just on one of those platforms, or can I have a application that is possible used by everyone, not restricted what kind of device this guy is using? That's a little bit the background, what we have to care about before we start designing software. We have to care about can we afford, how many users can afford a metropolitan area network? How many users can afford a cellular network? How many users have access to local network? How many users don't have access to any network? How many users have devices like smartphones or tablets? Yeah, do I need a tablet because all my information that I want to present is not able to show it on such a small screen a smartphone or a smart device has, and so on. Now, these are things we have to care about before we start working. I hope it was interesting for you too to have to look into this one. This is a typical theme. If you think about mobile computing in theory, you have to think about what is mobile, what is fixed, and is there a need to have something mobile, or can it be fixed as well? Questions so far? Okay. If not, let's have a look into the second point, the development environment. What you see here is a screenshot from the Android Studio. As I already said, I'm using IntelliJ for programming the Android platform. There's no need to install the Android Studio. You can use the IntelliJ Community Edition as well. So I just installed IntelliJ Community Edition and additionally installed the plugins needed to develop Android projects. But most Android developers use this Android Studio because it has the Android branding, Android in the name. It is maybe best supporting the development of Android, the best supporting IDE for development of Android. In the last 20 years or maybe 10 years ago, you could also, or one could also use Eclipse for developing Android, or NetBeans to other IDEs which are as well quite common under developers. And but since the Android SDK changed the toolchain to Gradle, it was only the best support is Android Studio, or comes from JetBrains with this IntelliJ or Android Studio since that. The others with their toolchain were a little bit out of it. Okay, Android SDK is one thing you need. It includes the toolchain. You can do with this SDK command line development. So there are command line development tools in this SDK, and those tools are form the tool chain. We need more of those tools in a row to create a application package which is installable on a mobile device that runs the Android operating system. And our graphical development environment, our IDE, uses those command line products to build out of your sources some application packages. This Android SDK includes all platform specifics for the different versions, and if we decide to or plan to develop for a distinct platform version, we have to download those specific files that are needed for the different versions of the Android platform, and there the API level has the main role if we try to figure this out. Then there are additionally emulator images. The emulator is part of the SDK. It is really simple to use Android, the Android operating system on a PC. We just have to run it a image in an emulator. Those images are part of the SDK, and the images are according to the operating OS versions. So we have platform API levels here. We found them here. We find them here, the API levels. So we need the support for our APIs to program, and we need a emulator that is as well able to run our API levels, but the emulator is conformant to the operating system version. So we get a emulator for Android 5, 6, 7, 8, 9, 10, and the platform to the API level 10, 20, 30, and so on. No. So here we have to bring it together as well. We have to think about which API level belongs to which operating system, so that we have the right emulator and we develop for the right application, the right API version, that our program is running in the desired emulator we have installed and run. If you do not want to program for the emulator, you can always use a smartphone and connect it to your development device, to your PC, I think, maybe laptop as well. Then you can test your software and run your software on directly on the mobile device. And yeah, we will use a emulator here in this course. It is more easy for me to present you things when running in the emulator. I don't need additionally a device which I put in the camera, and then my Zoom account removes the device, or my Zoom program removes the device, because it's not belonging to me as a person. Okay, what else? So Android Studio I talked about. It's a full-featured IDE and supported platforms for this Android Studio, or for this Android SDK, is the Wear OS. This is the Android variant for the wearables, so the smartwatches. I have here, this one is from Samsung, and if you want to program for this small device, it is really limited. We don't need all features that the Android platform has. It is not full featured, that's why it is limited. So we just have a limited variant of the Android operating system here called Wear OS, and we can make projects for that device type with the Android Studio 2. As Wear OS and TV, or cars, Android cars, Android TV, Chrome OS is also a variant, which is Chrome is coming from Google, which is possible to program for Android things. That's the platform when you use a Raspberry Pi, maybe, then you would program or use Android things for the intelligent devices, for the Internet of Things, small devices which are network enabled and which are not uniform. So the Wear OS are mainly the watches, so they have a small display and they have just 1, 2, or 3 buttons or something, and you can program this device. And the Android things do not have the need to have a display or something else. This is just maybe a sensor connected to the network and giving some data, sending some data somewhere else where you collect it and analyze it. Or it is a actor and switching some light on and off, or controlling some motor or something else. No. Very different things, so that's why it's called Android things. And we have at last but not least, the Android NDK. NDK is a development kit for native, so it's a native development kit. These are tools that you need to combine the Android platform with native code. You all know the Android operating system is based on the Linux kernel, and this Linux kernel is a computer kernel, operating system kernel, written in the programming language C. So far, this kernel brings lots of modules, or has lots of modules, which all are programmed in the C language, and therefore Android needs a binding between the features of the Linux kernel on the one side and the settings a user may make in the operating system on the other hand. So if you use your smartphone and you have ever changed the password of your wireless LAN, or you give in any settings that change some operating system features, then the Android application has to communicate with via some C code with the operating system kernel and the operating system, and that's why there's a bridge between native code and Android code. And to this bridge we have a development kit, so we can have own C or C++ or any other native library and get or program this library and use this library in our Android project. In our Java or Kotlin Android code can we use native compiled program code, and start it, run it, get data from it, and so on. And therefore we have these tools available. Questions for that? Okay, before we advance, we have 10 minutes left. I think we start a Android project and have a look inside. And on the other side, I wanted to tell you something about this Linux kernel. Why Google or the founders of Android decided to use a Linux kernel is the reason that we have a really secure kernel. The Linux kernel is small, running on almost or on quite every processor, because we have a C compiler that can produce code for every computer architecture, for small processors, microcontrollers too. So we have the possibility that we can produce a small operating system kernel for almost every processor. That's why for almost every device, could be a TV, could be a mobile device, a telephone, anything you can imagine which is using a processor and has enough main memory to hold a running kernel. And we have this GNU compiler which can produce code for those. That's why if I have a graphical user interface that is running on this Linux kernel, then I have a user interface running on that's possible to run on almost every device. It's the first point. Why we should use a Linux kernel. It's small and running everywhere. Microsoft's kernel is much bigger, getting smaller now because they migrate more to one system running on every device, but it takes lots of time. So 20 years ago they weren't ready to use Microsoft's kernel for this. And the next thing is we want to have something like Java. Java is running in a virtual machine. This is a sandbox. So we have code, and what is mobile is the application is as well the code. What is mobile? Is the code mobile? Can my code run on every device? So if I have a mobile application, I want to run this application on every device. So the Linux kernel is nice, running on every device. If I can compile it for, but the device manufacturer has to assure that his kernel is compiling for his device. So this is not your work. You don't have to figure out if your Linux installation is compiling on your PC or laptop or whatever. So you just take one that is ready for your processor architecture, computer architecture, take it, run it, ready. And that's a question of manufacturer or OS designer who is responsible for on which device is my operating system core running. Okay, Linux runs quite everywhere. And the next is we want to have mobile code. So if we use C as programming language, we have the problem that our C program can run on Debian, can run on Ubuntu but does not run on maybe Red Hat or OpenSUSE, another Linux, or any Linux system, Minix, or how they are all called. So there are different kinds of Linux variants, and if you have a source code written in C, it is not sure that this source code is running on every of these Linux installations. So this is a gap. This is a gap which Java has closed several decades before. So Java is nice because it has a virtual machine that is running on every device. We just have to compile it for every manufacturer's operating system, and then we have code that is really mobile. We can compile code, and this code can be run on any device. This is also a mobile approach of a application, of a program. The program is movable. And now we want to have this in a small device. If I take the huge Java virtual machine and bring it to a device, then I would have to say, okay, the device does not need Java AVT. The device does not need Swing or other stuff because it's too huge, it's too hard. We need a graphics card and so on. We don't have this. We have just an LCD display, and this is all. And we have some little memory. And that's why the Sun, as Sun was the owner of Java, created the micro edition of Java. They understood what we have to do. We want to have applications run on every device, so we create this micro edition. And we had the standard edition, micro edition, enterprise edition, and so on. And it was really small and limited. But not all device manufacturers used the micro edition. It was really much too limited. We could program midlets, so was it called, in the last century. Okay, so we needed something new because every device manufacturer was cooking his own soup. And now Google came with his Android approach and said, we take the Linux kernel, now we have a operating system we can run on every device. So we do not need the manufacturer, we can compile it for the device. If it is run, we have a running kernel on the device, we can use our software on this device. And that's why they thought about make it a little bit new. Clear out this virtual machine, remove it, and put it directly onto the kernel. So we do not have the need that the virtual machine is running on Windows, Linux, and so on. We just have to focus on one operating system, it's Linux. And that's why we don't need a huge virtual machine, just a small one. Just only one virtual machine that's running for Linux. And maybe the different derivatives we have from this. And other advantages we have won with this decision. This was a really important decision in evaluating a operating system for mobile devices, because when we focus on just one operating system, now we have the ability to use all opportunities this operating system gives us. And the Linux kernel has a really secure architecture. Every process can be separated since it is running under a user number. Every process is running under a user number, and on this user number are the rights of this process. So I can control the rights a process has while running on my device over the user IDs. And if you install a Android application on your device, every application gets a new own user ID. So every application is a new Linux user on your mobile device. So have you 30 applications? If you have 30 applications, you have 30 different users. They are just numbered and not named, but it's not a problem. You can imagine just give some number that are which is only for this application on your device, and everything's fine. And the rest can be handled, the security can be handled over the Linux kernel. And we do not have a sandbox, extra sandbox that is handled virtually, that takes us calculation time from our processor. It makes our device slow. So if we remove this part from the virtual machine, and we use it from the original Linux kernel, we win speed. We win processing speed. And this processing speed we now have for maybe graphical features. And we have a faster device, which does maybe consume less power. And this was the idea why we built, why a system like Android was built and came up out of all these. Java Micro Edition or the Symbian OS was another operating system. Then we have others. I think Mago, maybe you have heard about it, is another such a system. They all died because of Android came alive. Yeah. So that's something somebody who is programming Android should know from the background. We have from the design, from the system design, a really interesting system here. So now we are at the end of the introduction. If you have questions, please ask.
Yes, I have a question. So for this semester, our exams, are we going to be like writing more of a theoretical exam, or we're going to be like having like a practical maybe submission, maybe a project or something? We can just really just give a little bit of a light into.
Yeah. Okay. So thanks. The plan is that you do a practical exam during this semester, during this course. You get a task to create a mobile application running on a smartphone, Android application, and you finish this task until the semester or until the beginning of January, when we start again in January. The first 2 weeks, I think, you should give your solution to me, send it to me, and I will review your solution, test it, and then you get your note for this, and that's all. So we do not have a theoretical exam. The problem for a theoretical exam is that you are not all here in Hof, and we would have to do this online, and that's not that easy for all of you to do that. So I think it's more easy that you just show, okay, I understood how to use this Android, and program the Android operating system applications. And this is enough. I think it's not that difficult.
Yeah. Okay. Thank you very much.
Yeah, you're welcome. Okay, any other questions? So I hope you find this interesting. Today it was really theoretical. We talked about many things, and next week we will go more into the programming. So the next slides show this. We look into the program structure. We look into the SDK. We have a look at the tools. We have a look at some simple Hello programs or some simple testing programs, and talking about the basics, and then we advanced the fundamentals. We have some more complete view perspective of the activity and the intent system, and make examples for that. You see some more things here on the next slides, and that's part of the next week. And maybe we advance then to resources. I have to create some more slides for you here, or upload the next slides so that we can go on next week. So I hope you found it interesting for the beginners, and for the students, or the ones of you who already know about Android, who already program this Android. You could remember why we today use Android, and what is the reason for the success of this platform. Okay. Thank you very much. I wish you a nice weekend, and we see
you.
us again next
Yeah.
week. Bye. Think about
Thank you.
Procon.
Thank you
for
very
the
much. Yeah.
Okay.
Yeah, and it's for I also wanted to just point out because like it's a little bit of a new will I say challenge for me because coming from a background where I my first programming language was JavaScript,
Mm-hmm.
which is not very object oriented related.
Mm-hmm.
So I think I kind of like have to put in more effort into because I've seen the syntax like for the Android and it's kind of scary to me. I don't know, it's but I just wanted to like put in a leap of faith and hopefully I can grasp as much as I can in developing Android apps. Though I used to develop with React Native,
Mm-hmm. Mm-hmm.
so I usually don't go near the Java code at all. So like I run away from the Java codes. But now I think it's even one of the reasons why I actually want to like okay, I want to know what's going on under the hood and
Mm-hmm.
what's yeah. So yeah,
Okay, this
that's
is fine.
why
This
I
is fine.
chose
Yeah,
this.
yeah, yeah. It is the right way to
Um,
first think about: can I do it without a native Android application? My application,
mhm.
because I can reach several more devices, not only Android-enabled devices, others too. And since the thinking on other device manufacturers goes in the same direction, the browser applications are growing in features. So
Mhm.
if I program for the web platform more and more, maybe with JavaScript, this is the main language there, then the browser application on the mobile device, this is the thing which gives you the information from the native APIs and delivers it into your JavaScript. You can grab it from the
Yeah.
browser application and then communicate over network with your back office or server or whatever what else you want to do, and you have access then to sensors and things which the browser application gives you into your script, and you can grab it from there. But there is a little lack of security. If I access the wrong web page, this web page has maybe access to sensor information which I only want to give to this one website and not to the others. Yeah, and that's another thing we have to think about. So if we want to use the browser as the main application on our device, which has all access rights, other websites could use this to access information, contacts, and so on.
Yeah,
They shouldn't have
from the
access to.
device.
Yeah, and the
Yeah.
Facebook application and so on. They shouldn't access everything on our devices. No. Okay.
Yeah,
So
thank you very much.
yeah,
Yeah.
thank you too. You're welcome. Yeah, I wish you all a nice weekend.
Schöne Wochenende.
Ja, schöne Wochenende. Ja. Schön.
Okay. All right. Bye.
Goodbye.
Bye.
Bye. Bye.